Hi everyone, this is our guided notes for inferences from data, objective 1. And this is going to be what the title says, looking at data and then making some inferences or some conclusions about it. We do need some definitions first. So this first top box are going to be two definitions. One of this word mean, which I'm hoping you've heard before in math class. A definition for standard deviation, which you may or may not have heard from math class before. A little remember, like a hint that you're always going to use, and then we'll get into some examples. Okay, so the definition of mean, I'm going to erase this line and start typing in the definition. I'm going to type in the definition in red. If you have to pause this video to type it in your notes, that is fine. But the definition of mean that we are going to use is the average number of a set of data. And I want you to think about it as your center. So when I give you a set of data, it's the average, it's the center. Okay? So again, if you ever have to pause this video, feel free to pause to give yourself time to type. Standard deviation. The definition of standard deviation is how much you can vary. And then the key things here are above or below. And I'm going to put those in all capital letters. The mean. So this is how much you can vary above or below this average, the mean. Okay. And then the last thing we're going to type in here, and I'm going to do a different color just to kind of emphasize it, is what I want you to always remember is the smaller your, and I'm going to use SD, which stands for standard deviation, what we just talked about. The smaller your standard deviation is, the more reliable the data is. So the smaller your deviation, the more reliable the data. Okay, so again, if you have to pause, feel free to pause to get those definitions down. And now we're going to use these words in our problem. So here I'm giving you this example that your mean is 70, and then your standard deviation is 4. So I'm asking you, what is the spread? So this is what it looks like. 70 is, and I'm going to go off to the side here, 70 is our middle number. Remember, that's our average, our center, it's our middle number. Okay? Now, standard deviation is how much can this data vary above or below? So that means that it can deviate 4 below. So 4 below 70 is 66, but it also can deviate 4 above, which is going to be 74. I think about this, like if you talk about temperature, right? Like, oh, tomorrow is going to be a high of 74, but a low of 66. That's saying that really your temperature can deviate. Maybe the day says 70, right? It's going to be 70 degrees, but there could be a high of 74 or a low of 66. It's just saying that that day the temperature can really vary 4 above it, the mean, or 4 below. So it's just talking about data and how it can vary. So our actual spread will be 66 to 74 because it can go 4 below or 4 above. Okay. Let's look at some more examples. So example 1, Josh scored 2 standard deviations above the class average on his Algebra 2 exam. Okay. The class average, or the mean, was 75. Standard deviation of 3. What did Josh score? So let's I would suggest starting off by just listing this out again. So our mean is what? 75. Our standard deviation is 3. So that means it could go 3 above. It could go 3, and then what is 3 above? 3 above is 78, right? It could go 3 below, which is 72. This would be 1 standard deviation above and 1 standard deviation below. But remember, our problem says that Josh scored 2 standard deviations above. So we don't want to just go 1 deviation above. We want to go 1 more. So what is 3 more than 78? 81. So Josh scored an 81 because here was our center, and I can kind of highlight that to keep us our focus on that. 1 deviation above is 78, 2 deviations above is 81, so Josh scored an 81. Okay. Example 2, the average number of hours spent sleeping for a teenager is 10, with a standard deviation of 1. Nate only sleeps around 6 hours each night. How many standard deviations below the average does Nate sleep? Okay, so our average is 10, right? That's the mean. So I'm going to, again, highlight that. That's our focus. And then our deviation is 1. So every time we're just going down by 1. So 1 less is 9. 1 less is 8 from 9. 1 less is 7. And then 6, right? That's deviating by 1 every time. Now, Nate only sleeps 6 hours. So how many deviations is he away from the average? So here's our first deviation, our second deviation, our third, our fourth. So Nate is 4 standard deviations away from the mean. So he's like an outlier. You know, if the average is 10, he's kind of an outlier for this age group. Okay. Let's go to slide 2. We're still talking about standard deviations, but now we're going to look at graphs. So we're going to read this little paragraph and then we're going to label our graph. So let's see what it says. Graphs with small standard deviations, or they vary very little. An example of that is like our last problem, a deviation of 1. So they're only deviating by 1. That's very little, okay? So graphs with a small standard deviation or little variations are narrow because data is clustered around the middle. So this graph is going to be very skinny or narrow because all of your data is very close together. Okay. On the flip side, graphs with large standard deviations or they have a high variation are going to be wide or spread out because the data is very far from the middle. So if you had a deviation of 10, right, it's very spread out thin because your numbers are very far apart. So what this is asking us to do is why don't we label which graph has a large standard deviation, a graph that has a small deviation, and then one that's in between. So a small deviation, and I'm going to grab this box, this small box. That's going to be our blue graph because, again, the numbers are very close together. That deviation is very small. So look how my graph is very narrow and skinny. Okay. On the flip side of that, the large deviation is going to be this green graph because the numbers are spread out very far. The deviation's large. And then what we're left with is a medium is our red because it's somewhere in between small and large. So small would be like if your deviation's like 1, large would be around like, I mean, it could be any different numbers, but it could be something like 10 or 20, and medium is somewhere in between, maybe 5. Okay? So let's think about this as we go into our last problem, slide 3. Slide 3 is 2 other examples talking about kind of making inferences from deviation. So here we go. It takes Tiara 25 minutes to walk to school with a standard deviation of 5 minutes. It takes Marlene 30 minutes to walk to school with a standard deviation of 10 minutes. Whose travel time is more predictable? More predictable. Let's go back to our first slide. Remember our remember. So the smaller your standard deviation, the more reliable. So the closer your data is together, or the smaller your deviation, it's more dependable. You know what you're going to get. The bigger your deviation, you don't know what you're going to get. Like if you had back to our weather, if you had a weather day that said 70, but a high of 90 and a low of 30, you don't know what you're going to get. So the smaller your deviation, the more you can rely on it. So looking at this, it's saying who is more predictable or reliable. That means reliable. Well, Tiara's deviation is 5 minutes. Marlene's deviation is 10 minutes. So Marlene has more of this, you don't really know how long it's going to take her because it's a higher deviation. So Tiara is going to be the one that we can predict more or rely on more because her deviation is smaller. So Tiara. Okay. Example 2. Quiz 1 had an average score of 83% with a standard deviation of 12%. Quiz 2 had an average of 92% with a standard deviation of 7%. Okay, which statement is true? So let's just go through each one. So option A says scores on quiz 2 have a higher variability. So remember, quiz 2 deviation was 7, while quiz 1 is 12. So do we agree with this? Do we think 7 is higher than 12 as far as how it's going to vary? No. So I don't think A is right. Letter B, a score of 85% could not happen. Well, if we are starting, let's look at 83%, and it could vary 12 above or 12 below, and 92% that can go 7 above or 7 below. I mean, I think in between these numbers, because we're going above and below, 85 is somewhere in between 83 and 92, right? So I think it could happen. Really, any score could happen, even though you have a deviation of this, any score could happen. So I don't think that is good. Okay, C, scores on quiz 1 have a higher variability. So let's see, quiz 1 was deviating by 12. Quiz 2 is 7. Is 12 higher than 7? Yes. So that is our answer. I'm going to highlight that answer. All right, so those are your different types. You're gonna have a lot of word problems or possibly graphs. So just think about your definitions and then that hint in blue where if it's smaller, it's more reliable. All right, good luck on the quiz.